Now, for this part, there's a little graph to the right. The graph, I'll show you in a second why it's important. But we're going to try to find solutions by factoring. So it says finding solutions using factoring to solve for x. Right? So the equation we have is x squared plus 1 equals 4. Now, I made a mistake here, guys. Should be a 3 right here. Okay? So on your paper, you can change it to 3x squared plus 1 equals 4. Just add a 3 in front of the x squared. Then it's perfect. Okay. Otherwise, the solution isn't a whole number, and we'll talk about those tomorrow. Okay. So 3x squared plus 1 equals 4. I want to find a solution to this. Then you guys are probably saying, "Whoa, you said this was just like what we did yesterday." Then you're probably looking and saying, "This looks nothing like what we did yesterday." Right? Right? Okay. So how can we make this look like something we did yesterday? Okay, Yovan needs to subtract 4. Right? If I subtract 4, does it look like we did yesterday? Well, we have to do algebra, right? So we subtract 4 from one side, we've got to subtract it from the other side, don't we? Right? So now, 1 second, Serena. So now, is this what we did yesterday?
Yes.
Parabola equals 0. Just like what we did yesterday, isn't it? Yeah. So I didn't lie to you. Okay? So then from here, that's what we did yesterday. Okay? Serena, what's your question? Yeah, that's fine. Okay. All right. So we do some algebra, and then we can we do some algebra, and then we end up making it look like a parabola with our parabola where we're finding the x intercepts. Right? So if I'm going to solve this equation, I'm going to find the x intercepts of this parabola. All right? We need to factor, right? That's what we did yesterday, isn't it? Right? We need to factor, right? Okay. The first thing we should do is common term factoring, right? Is there a common term in here? Is there a common term? 3. Good. So we pull a 3 out of everything, right?
Yeah.
So I take a 3 out of everything and we get this. Now you're probably saying, well, Mr. Branch, we didn't do that yesterday. I know we didn't do one just like this yesterday, but it's the same general idea. We've dealt with factoring. We had to pull a common term out before, haven't we? All right, so same thing. Everything all right?
Yeah.
Okay. Any questions about that? Any questions about that? Okay, does that make sense?
Yeah.
Yeah. Okay. Now, I want to factor x squared minus 1. Now, this one, what's my b term? 0. It's hiding a b, right? So, b is always on x, right? So, this one's hiding that b term. So, there's 2 ways to do this one. I can either recognize that this one fits the form like that, a squared x squared minus b squared, right? Or I can just do my normal boxing, right? Either way works, okay? If I recognize it fits this form, then I know my answer will look like this, right? So we're getting some practice with a special case while we're going through this one, right? Or I can box, right? If we box, we do this, right? Because my b term was 0, right along? Okay. Remember how normally a parabola looks like this? Ax squared plus bx plus c, right? Ax squared plus bx plus c. So if I have it like this, a is 1, c is -1, where'd b go? Okay, so b is 0x. Okay, does that make sense now? All right. So now I need to multiply a and c, right? 1 times -1 equals -1. Now, what are the factors of -1 that add to 0? -1 and 1. Right? Does that make sense, Shamira? Yeah. So that means this is really 3 times x squared minus 1x plus 1x minus 1. Right? Right? Yep. So now I can box, can't I? Yeah, box over here. A little more space over here. X squared minus 1x minus 1. So what's the GCF? 1x. GCF? 1. GCF? 1x. GCF? -1. Right? So x minus 1, x plus 1, right? Right? Does it match that form? Yeah, it does. What's A? 1. What's B? 1. Okay? It matches that form, doesn't it? Right? So we could have, instead of boxing, you could have just jumped right to this and said your answer was x minus 1, x plus 1. Okay? But if you want to box, that's fine too. Either way works. Yes, Bruno? We do need to put the 3 in the front. So that's this part factored, right? Right? So then the equation we're working with then is this. 3 times x minus 1, x plus 1 equals 0, right? I'm still trying to solve, aren't I? Guys, I'm still trying to solve, aren't I? Yeah. So how many solutions will this have? 2 solutions. How do I find my 2 solutions? How do I find my 2 solutions? X minus 1 equals 0. X plus 1 equals 0, right? We just algebra our way through. Okay. Good. Add 1 here. X equals 1, right? Subtract 1 here. X equals -1. So then those are our 2 solutions. Does that make sense? Guys, does that make sense? You see how it's a lot like what we did yesterday?
Can you do another one?
Yeah, we'll do another one in a second, okay? But the thing that we change is at the front, right?
Yeah.
We take whatever's on the right side and move it over here, don't we? That's the only difference. So that way, by doing that, we end up with something that looks just like what we did yesterday. Find the x-intercepts of a parabola. Right? Why can't we do it just the way we did it?
Yeah.
Because sometimes we're looking for x-intercepts of a parabola, right? Which is what we were doing yesterday. Right? Sometimes I might just get an algebraic equation. So this is just saying, if you look at, I'm just finding solutions, right? I want to find the x that makes this true. Right? So what I'm trying to show you is that the same tactics you use to find the x-intercepts of a parabola are the same techniques you use to solve for x here. Okay, does that make sense? So like, let's say this problem they're saying, when does 3x squared plus 1 equal 4? Okay? You see the difference? Find the x-intercepts of this parabola, and when does 3x squared plus 1 equal 4? Those are 2 very different questions, right? Just from the start? But they're solved the same way. So I'm trying to help you make that connection. Does that make sense? So it's not that the problem is completely different. It's just the way I ask the question is different. Okay? All right. So we've been looking a little bit at graphs, so we've been going through this too. So what's the parabola we graphed? If I wanted to look at the parabola I used in this equation, what was the parabola that I graphed? That we found the intercepts of? Wasn't this 3x squared minus 3? Yeah. So if you type that in your calculator, you don't need to because I can just put it on the screen. Okay? Here's the parabola for 3x squared minus 3. Okay? Where does it cross the axis at? -1 and 1. Those are our solutions, right? Okay. There's 2 other equations we looked at. X squared plus, or 3x squared plus 1. This will make a parabola, right? And y equals 4. This makes what kind of line? Horizontal line, right? So here's y equals 4. See that horizontal line? Crosses at 4. Here's 3x squared plus 1. Okay. Now if you look, there's -1, right? Where do these two cross? Same spot, -1. Okay, do you see that? Do you see that? Okay. So here, intercept is 1. Where do these cross? 1. So what I'm showing you is that these two are equal when x is 1 and -1, just like these two, my parabola crosses the x-axis when x is 1 and -1. So I've showed you algebraically how they're the same and both graphically. All right? Does that make sense? Okay, does that make sense? So if you want to draw a picture on your notes, maybe draw a picture of the two solid lines crossing at 1 and -1, and then draw a picture of the dotted line crossing at 1 and -1, and make a little note that this solid line is y equals 4, right? The solid parabola is x squared plus 1, or 3x squared plus 1, right? And the dashed parabola is 3x squared minus 3. So make a little note for yourself to show you that these things are all, even though we made a small adjustment, it still does the same thing. Okay. Now, if you were solving this problem, would you have to draw the graphs? No, you would not need to draw the graph if you're solving this problem. Okay. The graph is just to show you graphically they're the same thing. Does the process make sense, guys? Does the process make sense? No? Get everything to one side. Parabola equals 0. Find the x-intercept. Same thing we just been doing, right? You guys? Okay. Yeah, we're just paying attention. Yeah. I just go by what David tells me. David doesn't lie. That's a lie too? Okay. You know, I saw on the internet one time, don't believe what you see on the internet. All right. Any questions? Are there any questions about what we did here to get started? Because there's no b value. B always has an x on it. There's no b, then the b is hiding. If there's nothing with an x, then b is hiding.
How do you know the buyer?
What?
Is that how I get to
Okay, so like here there's no x value, right? There's no just something with x. So that means b is hiding. Okay? And it just means b is 0, so you just write 0x in there. Okay, and then we know the factors have to add to 0. All right? Okay if I erase this? Yeah. Okay. Now the next part says finding intersections. Now you're probably looking at that one saying, "Oh my goodness, Mr. Branch has 2 equations here. This looks confusing." Who's in that boat? Who thinks these 2 equations look confusing? Anybody? No one raised their hand, so that we're all good. The next part says finding intersections. Right? So go down the page a little bit. Right? Versus finding intersections, y equals x minus 1, y equals 6 over x. Right? I want to find where those 2 graphs cross. Okay? Now you're probably thinking, how is this like parabolas? X squared minus 1, what does that make? What does x squared minus 1 make? Or not x squared, sorry. What does x minus 1 make? A line. Right? It's a line. What does 6 over x make? Does not make a line. Close. A butterfly! You said, I'm sorry. I should put it down first. I'm sorry about that. Alright? So, x minus 1 is this line, right? Right? 6 over x is this butterfly, right? Okay, can you draw those on your paper? They don't have to be perfectly. They don't have to be the exact points. Just qualitatively draw them on your paper. So they look just like that picture. That'd be great. Okay? Now, how many intersections, and this is on the second graph, the first graph we already did the second graph. So, how many times does the line intersect the butterfly? Twice. How many times does a parabola, or do most parabolas, intersect the x-axis? Twice. Can you kind of see where we're going with this?
No.
Okay. So, line intersects butterfly twice. If I draw a parabola, it intersects the x-axis twice, right? So I need to figure out a way I can take these two equations and turn them into a parabola. All right? And if I can do that, then it's the same thing that we've been doing. Okay? Now, when two equations intersect, what does that mean for the two equations? It means they equal each other, right? So I want to turn these two equations, y equals x minus 1 and y equals 6 over x. I want to turn that into a parabola. And our first step is what Long just said. If they intersect, that means they are equal. So I take the two equations and we write them equal to each other. So all you do is you do this. X minus 1 equals 6 over x. Okay? Because if we're intersecting, if we're at this point and this point, that means that the two equations are equal. Does that make sense, guys? Where they intersect, that's where the two are equal. Right? We're way back solving system equations by graphing. The solution was where they cross because that's when the equations were equal. Right? Same thing here. All right, you guys with me? Yeah? Yeah. Now, on the previous problem, we want to get a 0 on one side, right? I want to do the same thing here. I want to get a 0 on one side, which means I want to take everything from one side and put it on the other side. Okay, it's probably easier if I move the 6 over x to the other side. Okay? But do parabolas usually have x on the bottom? No. So I need to first get the x off the bottom. Faith, try it, please. Okay, how do we get x off the bottom? Multiply, good. So we multiply by x, and I need to multiply this whole thing by x, right? Right?
Yeah.
Distribute my x. X times x is?
X squared.
X squared. X times negative 1 is?
Negative 1x.
Negative 1x, greater or negative x. These x's cancel. Uh-oh. We're getting closer to a parabola, aren't we? Okay. Now what do I need to do?
Minus 6.
Subtract 6. Can I subtract 6 from anything? No. So x squared minus x minus 6, right? Nothing's like. What do I have now?
I don't get it. Isn't that a 1? It's like a negative 1?
Right, but this has an x on it. That doesn't.
Okay.
They're not like. Right? Good question. What did we just make? X squared minus x minus 6. What is this? So it's the parabola. It's the regular thing. It's what we did yesterday, right? And by saying equal to 0, I'm finding the x-intercepts of this parabola, aren't I? Right? I'm finding the x-intercepts of that parabola, right? So, you may notice that I have this equation right here. Okay? So I'm going to turn this parabola, it's going to be dashed. Okay? How many times does it cross the x-axis? Twice. It crosses here and here. So yes, if I was looking for an approximation, you guys could just tell me the numbers off the graph. That'd be fine. Okay? But I like to be exact, so we're not going to do it that way. We're going to factor. All right? Now, what do you notice about where it crosses the x-axis? The line and the butterfly cross the same point, don't they? Right? So it's a lot like the last problem. Okay? By taking these two equations and rewriting them and making them a parabola that equals 0, right? We can find their points of intersection. Now, will that give me the x value or the y value for their intersection? X. So by finding my x-intercepts of this parabola, I'm finding the x values of those two intersection points. Does that make sense, guys? Yeah? So how can I find the x-intercepts of this parabola? I'll give some more room. Okay. We can do the box, right? So to start the box, what do we have to do? Okay, I'll do it over here. I want to draw the box. We do a times C. So 1 times negative 6, what does that equal? Negative 6. Now, if the factors of negative 6 that add to negative 1, right? So the factors of negative 6 that add to negative 1, what are they going to be? 2 and negative 3. Right? Does that make sense, guys?
Yeah.
Yeah, we've all done it before, haven't we?
Yep.
Okay. So now I can do this. X squared plus 2x minus 3x equal, oh, forgot my negative 6. Minus 6 equals 0. Right?
Yep.
What's the next step?
Can you ignore the 0?
Box it. Yeah, you can ignore the 0. Just like we did yesterday, right? X squared, 2x, negative 3x, negative 6. So we're boxing.
1x.
GCF?
1x.
1x. Negative 3. 2. So our factors then are x minus 3 and x plus 2. Right? Right. So if we were just factoring, we'd be done, wouldn't we?
Yeah.
But we want to find intercepts, don't we?
Yeah.
So what do I do with the x minus 3 and the x plus 2?
Change it the opposite way.
Algebra, we set each of these equal to 0. So x minus 3 equals 0. X plus 2 equals 0. Right? What do I get here? Plus 3, thank you. So x equals 3. Minus 2, thank you. So x equals negative 2. Okay. So, I'm going to bring my graph back and we're going to see some confusion over here. But just remember that x equals 3 and x equals negative 2. Those are our solutions, right? Those are the x intercepts. Okay? So here's our graph back. I guess the confusion is as bad as I thought. Alright? So, this point right here is negative 2, right? Right, guys? Right, Long?
What?
That point right there is negative 2, right?
Yeah.
And this point right here is
3.
3. Which means this intersection point is 3 comma something. And this intersection point is negative 2 comma something. Right?
1, 2, 3.
Okay, you're just counting now, aren't you, Long?
Yeah.
Now let's say we didn't have a wonderful graphing program like this one right here.
Calculate.
Okay? Calculator. How would I use my calculator? Okay. I'm going to erase everything we've done. Okay, I don't want you to do that. I want you to leave it on there. Except for our solution part, so that we can kind of focus on what we have. Okay? So, we have these two equations, right? These are my intersection x's, right? Right? So how can I find the y's? Plug them in for x. Right? If I take this negative 2 and put it in for x in either equation, should we get the same number? Yeah. 6 divided negative 2 is negative 3. Negative 2 minus 1 is negative 3. Okay? So 6 divided negative 2 equals negative 3. So that means this point right here is negative 2, negative 3. Right? Over here, 6 divided 3 is 2. So that point is 3 comma 2. Okay? You're lost, Jamira? Where'd you get lost? Did you understand the intercept part? How I found the x intercept to be 3 and negative 2. You understood that part, right? Okay. So that 3 and negative 2, that's where the parabola crosses the x-axis, right? That's also where these intersect, right? Does that make sense? So then I know the x values are negative 2 and 3 for the intersections, right? So then to find the y values at that point and that point, you plug your x's into either equation. And that equation will give you the y. Okay? Because if 3 is my input, it tells us what our output is, right? 3 minus 1 is 2. Right? Negative 2 is my input, right? Negative 2 minus 1 is? Nope. Negative 3, right? Does that make sense now? Okay. So that's just a little bit more you have to go. All right. But the tough part, guys, is find those x's, right? And find those x's is just like finding the x-intercepts for a parabola. Okay. Are there any questions about that? Any questions? We'll try some more. Okay. No questions?